All right, so we are doing lesson 7, which is plot match. So unit 2, lesson 7. And we're going to be talking about different plots that we've been introduced to in the past. Okay. And thank you for being helpful in the chat to your peers there. All right, so our objective for the day, okay, our objective for the day is that you will learn how to create a box plot. Now, we already learned that, right? We've learned how to create a box and whisker plot, but this time around, you're going to be creating a box plot from an already created dot plot, okay? So the whole point of today is that we're going to be pulling information for a box plot from a dot plot, okay? Now, the essential concept for today, the takeaway, is that box plots are an alternative visualization, okay, of histograms or dot plots. They capture most, but not all, of the features that we can see in a dot plot, okay, or a histogram. So each of these plots, a dot plot, a histogram, or a box plot, they each offer some level of information that maybe the other one might not. They each represent a distribution of a variable, but they each also give maybe some information that the other does not, okay? So first things first, let's review about dot plots, because we did dot plots in lesson 5. That was a week ago. I know, it's like a decade ago for you guys, right? But no, that's been a week. So let's review from lesson 5, right? A dot plot, I'm sorry, not a dot plot, a box plot consists of these different values here. It has the median, right, which is that middle value of our data, okay, the middle value. It has our quartiles. Each value of a quartile represents every 25th percent, right, of the data. So each quartile value represents the 25th percent of the data. So quartile 1 is the first 25th percent. Quartile 2 is another 25th percent to include all 50 of the first half. Quartile 3 is another 25% to include 75% of the data. And then quartile 4 is 100% of the data there, okay? And then, of course, we have our minimums and we have our maximums. Okay, minimum is our lowest possible value. Maximum is the largest possible value there, okay? So, all right, sorry about that. So, how then do we find these values, right? How do we actually find the values of that go into our box plot? Okay, so again, recall from lesson 5, right? We have our minimum and our maximum, so we want to make sure that our data is listed from lowest to highest, right? And then, so that the lowest and the highest will then give us our minimum and our maximum, right? And then we go ahead and we find our median, which is our middle half. And we find the median by splitting our data in half, and we literally find the smack dab middle data point. If the middle doesn't exist and there's 2 numbers in the middle, then we have to average those 2 numbers, yes? And then once we found the median, the middle half, that leaves us with the lower 50% of our data and then the higher 50% of our data, right? So then what we do is we take the lower 50% of our data and we find the median of that data, okay? So same process as finding the median for the whole. We find the median of the first half, and then we find the median of the second half, okay? And that gives us the 5 numbers that we need in order to create a box plot, okay? So I know I didn't list those exact 5 numbers that we needed. That's because your first IDS entry right now is actually going to be you answering the following questions in your IDS journal. What are the components of the 5 number summary that make up a box plot? what are the 5 numbers that you need in order to make a box plot, okay? And then, more importantly so, what information does each component of the box plot tell us? So you can literally put, this is what it is, or this is what was one of the numbers I need, this is what it gives me. This is one of the numbers I need, this is what it gives me. Okay, 3 minutes to do this. Okay, Alexis, do you have a question? No? Okay, so you're going to give me what are the components of the 5 number summary in your journal for 3 minutes starting now. And then of course I'm going to call on people to share. So be at the ready, people, be at the ready. Okay. All right, ladies and gentlemen, that is our time. So our 2 questions, what are the components of the 5 number summary that make up a box plot, and what information does each component of the box plot tell us? Okay, let's see. Maya, can you please answer our first question for us?
Yeah, I can.
Go ahead, hon.
So I said the minimum and the maximum values, and then the lower and upper how do you say it, quartile,
Quartiles, yes.
as well as the median.
Okay, so we have the min and the max, and we have the lower quartile, the upper quartile, and then we had the median, right?
Yes.
Okay, very good. What's another name for the lower quartile that we were using?
The first quartile?
Yep, the first quartile. Very good, Alexander.
The.
And then the third, right?
Mm-hmm.
Very good. Yeah. So other names for it are the lower and the upper quartiles. Absolutely. So we also were using Q1 and Q3 here. Very good, guys. Awesome job. So when we are using our 5 number summary here, right? What does each value give me? And guys, don't overthink this question, okay? You shouldn't have overthought this question. It's very basic. It's literally asking you, what's the definition of each one of these, okay? So can I get Dario? Dario, can you help me out with that?
With each component?
Yes, please.
All right. I just put it in my journal.
Yeah, no worries.
So it tells us the minimum, the maximum, the middle of the median, and the minimum, the middle of the minimum and the maximum, and the middle of the median and the maximum, which is like it's minimum, maximum, Q1, median, and Q3.
Okay, but let me ask you, what is the actual minimum? Like if I was looking for the minimum, how would I find it?
You'd find the lowest number.
Okay, so if I was looking for the maximum, how would I find it?
You'd find the highest number.
Okay, so that's what I mean by what is each component in the box plot tell us, right? So if I was looking for the median, how would I find it?
You'd find, you'd count all the numbers up and then look for the middle number.
Good.
And, yeah.
Okay, and then what about quartile 1?
Quartile 1, you find the 25% of the the line of numbers. So you'd count like half of the minimum and the median.
Very good. So halfway between the minimum and the median is Q1, and then Q3 is halfway between the median and
the maximum.
The maximum. Very good. Okay, so that's what our numbers tell us, right? More specifically, quartile 1, right, is the value of the 25th percent of my data. It's the value at 25% of my data. And quartile 3 is the value at the 75th percent mark of my data, right? Because at quartile 3, I'm saying this is the value that is 3/4 of the way to my data. Anything below this is 75% of my data. Anything above it, right, is part of the upper 25% of my data. So thank you, Daria. Well done, hon. And Alexander, great job participating as well. Okay. And a few of you in the chat, Maddie and Janelle, thank you for your participation in the chat as well. So really quickly, I just want to review, how do we actually use these numbers, right, to create a dot plot? So, or not a dot plot, box plot. Am I going to make that mistake all day today? Because that's going to irritate me, guys. You're like, not my problem, Miss K. And I just deleted my line instead of, all right. So if I have my number line here, right, my really horribly made number line, right, usually your minimum is what starts you off. Okay, that's your min. And then it goes on to your quartile 1, wherever your quartile 1 is going to be. Okay, and then you hit your median, wherever that may be. And then you hit the quartile 3, your third quartile, and then you go to your maximum. And I'm purposely not making them the same length apart because that hardly happens. Okay, and so remember the box and whisker plot, right? The box plot. So the box is created with your Q1, median, and Q3. And then the whiskers are Q3 to the max and Q1 to the min. Okay. So the box is your middle 50%. Okay. And then your whiskers are, this is the upper 25%. Okay. Top 25% and lower 25%. Okay. So that makes 100% of your data, right? So that's our box and whisker plot using our 5-number summary. Minimum, Q1, median, Q3, maximum. Okay. So knowing how to create a box plot is incredibly important, right? Because especially we want to be able to pull these numbers from another given visual representation. So suppose we were given dot plots instead, right? Suppose we were given dot plots instead. Well, if we were given dot plots instead, then we need to be able to pull out information. So a box plot is only one representation of the distribution of a variable. Okay, so remember, we're only looking at one variable with a box plot, with a histogram, a dot plot, or wherever. We're only looking at a variable at a time. So a box plot is one representation of how that variable is distributed, right? We can see the center of the variables, we can see its variability, right? The spread. But we also have worked with other representations of distributions. We can also use a histogram to show how a variable is distributed. We can use the dot plot. We can use a bar chart. Remember bar charts, AKA bar graphs, right? They were literally like, they look like histograms, but we use them for specifically other types of variables, right? But they were still bar graphs. We have scatter plots. We've seen scatter plots before. Okay, and then of course we've seen tables, specifically frequency tables, different types of frequency tables, right? So you might not think we've learned a lot, but we've learned quite a bit because we have seen all of these different types of representations of data. Okay, representations of one of our distributions. So what we're going to do is in our journal, we're going to do a bit of organizing. Okay. In your IDS journal, you're going to make a 2-column chart. One is labeled single variable. The other is labeled double variable. Okay. Oh, yes, of course. I'm sorry. You were writing that down. Absolutely. Okay. So I will explain our journal while some of you guys are getting down the notes. Okay. So in your journal, you're going to, you already have a 2-column table. One of them is labeled single variable, the other one is labeled double variable, okay? What you're going to do is you are going to take each of these visual representations, okay? Each of these visual representations of data, the box plot, histogram, dot plot, bar chart, AKA bar graph, scatter plot, and tables, and you're going to categorize them either as a single variable graph or a double variable graph. So what does that mean? That means, is each one of these representations, does it represent one variable at a time, or are you using two variables or more at a time, or two variables, let's stick to two, right? So is this a one variable representation every time I create something with this, or is it a two variable representation? Am I comparing two variables? Am I trying to find a relationship between two variables, right? Or is it one variable at a time? So you're going to place the name of each distribution into these two categories, single or double. Then you're going to justify why you put them in that column. Okay, so we have a dot plot, bar chart, scatter plot, histogram, table, aka frequency table, and a box and whisker plot, a box plot. Okay, so what you're looking at, I'm sorry, it's going to show my email very quickly while I go over to our lessons here. So what you're going to see in your journal is this. You're going to put the graph name here. You're going to tell me why you put it under single or double. Okay, I'm going to give you guys 3 minutes for this, 3 minutes. And I'm going to go back to the PowerPoint so you guys can see the list. Okay, all 6 of these need to be categorized. 3 minutes. And yes, I will be calling on people to give me a graph where they put it and why they put it there. Okay, 3 minutes starting now. Okay, ladies and gentlemen. So we have, let's see here. We have 6 graphs that we need to classify. Okay, and I'm going to head over to my my journal here. Okay, head over to my journal here. All right, I did message a few people, not all of the people, I didn't get a chance to, but let's get started here. Okay, so first graph, any graph that you classified. Trinity, can you give me one graph that you classified under single or double and why? Trinity?
One moment, please.
Okay. Okay, Trina, I'm going to come back to you, so please be prepared after the next person. Oh, wait, Valerie, yeah. Valerie, why don't you go ahead and share yours while Trinity gets hers together.
Well, I didn't get to finish, but one of the things that I said was histogram would go under single variable because it counts the frequency of how many how many times it was said. So you just need one variable.
Okay, so you said a histogram is single variable because it's a frequency of one variable, right?
Yeah.
All right, so it shows us the frequency of one variable. That is really horrible writing there, guys. Let me see if I can write that a little bit better, just in case you guys need to see it a bit better. Okay, so histogram, because it shows the frequency of one variable. All right, right on. So if we think of a histogram, right, we have our bars and we have numbers down here and it's the values of our variable. But this right here is always the count, right? It's our frequency. Very good. Thank you. All right, Trinity, we are back to you, hun.
Okay. That's my screen because I was still typing.
Just give me one.
Okay.
All I
Okay.
need is one.
So mine is bar graph and it's a single variable
And why?
because you can just specify with one variable. It's more particular than a histogram. Like,
Okay.
specified than a histogram.
Okay. So bar graph, your same idea, right? It's showing us the frequency of one variable, and you're saying it's a little bit more specific than a histogram.
Yes.
Okay. Okay, good. Thank you. Next up we had Dallas. Dallas, let's have Dallas share one with us. Dallas, hun, you there? Okay. Janelle.
Yes.
Janelle, go ahead and give me one, hun.
Okay. I put dot plot also for single variable.
Okay.
And I said the same thing also, like the frequency of variability.
Okay, so it's giving us the frequency of one variable. So, okay, so I'm just gonna put these guys instead of writing it. Okay, so we have a bar graph, right? Same thing, variable, and we have our bar, and again, we have the count, right? And then we have our dot plot here. But again, values of the variable. And then we have our count here. Okay. All right. Evelyn. Evelyn, give me one of yours, one that we haven't said yet. Okay. So we still have scatter plot, we still have table, and we still have a box plot. So, Evelyn, do you have one for me, my dear? I know you were there a second ago. Aha. Okay, so Evelyn is saying a scatter plot goes in single variable. Okay, Evelyn is saying scatter plot goes in single variable. Let's think about this. A scatter plot, right, looks a lot like a dot plot. Yeah, looks a lot like a dot plot where we have dots everywhere, right? That's our scatter plot, scatter dots. We have a variable here, but on the y-axis, are we counting these dots? Are we giving a count, or are we comparing it to another variable? Look at the y-axis. Are we giving it another variable to compare to, like this dot right here? Okay, we aren't counting. We're comparing it to another variable. So for a scatter plot, we're doing variable versus variable, right? So this is actually a double variable. But I'm glad that you made that comment, Evelyn, because it made us talk about our situation here, right? So we are comparing the relationship between variables. Okay. We are comparing the relationship between variables here. All right. Let's see. Thank you, Evelyn. Well done, hon. Good conversation starter. Let's get Jade. Jade, do you have one for me? Jade, going once? Jade. Going twice. Oh, okay, you're typing. Got it. Okay, while you type, Jade. Hey, let me have Alexander.
I said a dot plot is a double variable because it uses a second variable may be used to divide the first variable into groups.
Okay, so you're saying a dot plot is, okay, so yes, with splitting, we end up looking at two variables at a time, right? You get a dot plot and you get a dot plot, but each individual dot plot is still a plot with one variable,
Oh.
right? All we do is we
Mhm.
split the data we're using, right? We're splitting the data we use, but each individual dot plot is still only looking at one variable's distribution. Okay. So that's why when Sarai asked, are we ignoring splitting and faceting? We're not necessarily ignoring it, right? But we're just looking at each individual plot is only showing us the distribution of one variable. So it's not a comparison of two variables. Okay. And then oh wait, who is that I was calling on earlier? Give me a second. Jade, thank you. Jade said that a box plot is a double variable because it compares from two or more groups. Jade, thank you for that, right? A box plot, we have 5 numbers we're pulling from, right? For our box plot. But where are all of those 5 numbers coming from? Are they coming from the same data set, same variable, or are they coming from different variables? For a box plot, are all these 5 numbers, are we using the same data set to get them, or are we using different? Yeah, we're using the same variable. All 5 numbers, it's literally the splitting of the same data set, right? So we're only using one variable here. So a box plot is actually a single variable representation. Okay, it's actually a single variable representation. Okay? And again, it's because we're looking at the frequency of one variable. All 5 numbers come from the same data set or variable. Even though we're splitting the variable into parts, right? Which you're right, we're splitting them into little groups, but it's still the same variable that we're looking at, okay? All right, this leaves the table. Anyone have anything on the table? Did anyone determine anything about the table? Let's see if we're gonna have a volunteer. Where would the table go? Aha, very good, very good. Okay, very good. Yes, 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 yes. The table goes under a double variable. Okay, because once again, we are comparing the relationship between two variables. Okay. It can actually, Maddie, yes. Yeah, a table can be double variable and it can also be single variable. It can be both because the table, right, is a comparison of two categorical variables. Just like a bar graph is a count of a categorical variable. Okay? A bar graph is a count of a categorical variable. As opposed to a scatter plot that is a comparison between two numerical variables, and a histogram, dot plot, and box plot are all counts of numerical variables. They are all counts of numerical variables. Okay, so some nice review there for you guys. Because you have to realize it's important to know when to use what kind of variable. Okay? If you make a histogram with the gender variable, if you try to make a histogram with a gender variable, gender is categorical, right? Gender is either male, female, or if you have a third option of non-binary, right? Gender is categorical. So if you try to make a histogram for the gender variable, you're gonna get a warning code because gender is categorical, whereas a histogram is meant for numerical variables. A dot plot is meant for numerical variables. Box plots are meant for numerical variables because you're dealing with number values, right? Same thing here. If you try to make a table for a numerical variable, oh my gosh, it's going to be crazy. It's not going to do it. Okay, it's okay, Dallas. It's not going to do it. Okay, so you make a table to compare categorical variables, right? Male and female versus blue eyes, black eyes, or I'm sorry, blue eyes, brown eyes, or green eyes and hazel eyes, right? So eye color, right? Gender versus eye color. You can do that. Those are both categorical variables. But if you want to compare height versus age, those are both numerical variables, right? Those are both numerical variables. So you would have to use a scatter plot. So you have to know if you have a categorical or numerical variable and what kind of visual representations are meant for numerical versus categorical. Notice categorical is very limited, right? You have a bar graph and you have a table, like a frequency table. That's it for categorical. So you have to be very careful. Okay. Now you can facet and you can split a numerical variable with a categorical. So you can say, I want to look at the heights of males and females. I want to look at the heights of males and females. So then that's when the faceting comes in, where you get two histograms, right? Or two dot plots or two box plots in this situation. One is only using the male data and the other is only using the female data. So you can split your numerical data based on a categorical, but what you're still graphing is the numerical. Okay, so it's really important that you understand those distinctions. Okay, I hope you guys had that down. I should have asked before I did that, but my bad. Oh, there's an undo button. Anyone need that? Anyone need to screenshot all of this? Okay. All right, perfect. Thank you. So this is going to take us back. We're going to go back to our PowerPoint. So it's going to take us to our first activity, okay, our first activity of the day. And you guys are going to be given about 15 minutes for this and no more, okay? 15 minutes for this because we are already running out of time. So 15 minutes, it's going to be 2.7a from dot plots to box plots. So what are you doing here? You are going to be looking at these two dot plots that are showing the test scores data for two classes, Class A and Class B, okay? Your instructions are the following. Create a box plot of the data for each class. Use what you have learned about components of a box plot to sketch them using the data from the dot plots. Then compare the two box plots and answer the questions that follow. Use the evidence from the data to support your answers, okay? So first things first, you're gonna draw a box plot for each of the classes. So Class A, I'm gonna help you out with, okay? So we take a look at this dot plot here. From this dot plot, we want to get our 5-number summary because in order to create a box plot, we need our minimum, okay? We need our Q1, we need our median, we need our Q3, and we need the maximum. This is for Class A, okay? So for Class A. So the minimum and the maximum should be really easy to see. Here's my lowest dot, here's my highest value dot, right? So this is going to be a 7 for my minimum, and my maximum is a 14. There's my minimum and my maximum, okay? So from there, I need to find the median. I need to find my the median first, and then I can find my Q1 and Q3 based on that. So if I take a look here for my median, I have to know how many data points there are. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. Okay, so how do we find our median? We take 20 and we cut it in half. So we can see what is the halfway mark. Okay, and that's 10. That's a whole number. What that means is that this is going to be split into 2 groups of 10. So my median is actually going to fall between the 10th and 11th values. The 10th and the 11th values. So I'm going to go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So here's 10, my 10th and 11th values. My median is whatever number is the average of those 2 values. Both of those values are actually 11, because that's 11 and that's 11, right? That's above the 11 mark here. So that's 11 and that's 11. So 11 plus 11 divided by 2 is still 11. So my median is 11, only because 11 plus 11 divided by 2 is still 11. I averaged those 2 values, okay? So now I'm going to split my data into 2 halves. So I have this group right here. This is my first 50% of my data. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And then my other 50% of my data is the rest of this column right here, and then over to the left. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay. So now I need to find the middle of this 10 and the middle of this 10. So how am I going to do that? The same way I did this. I'm going to take the 10 values and divide it in 2 to see what the middle value is. That's a 5. Again, it's a whole number. So I'm going to be looking at the 5th and the 6th term. I'm going to be looking at the average of these 2. So 1, 2, 3, 4, 5, 6. So here's 5, 6. I'm looking at the average of 5 and 6 here. Luckily, the 5th and the 6th dots are above the value of 10. So this is going to be a 10 plus a 10 divided by 2. That's still a 10. Okay. My Q3, now I'm looking at this half of the data, starting from the lowest dot here in the data. Okay, same idea though. This also has 10, so it's the 5th and the 6th, the middle of the 5th and the 6th term. So 1, 2, 3, 4, 5, 6. So here's my 5th and 6th term. Right in between them, this is a 12 and this is a 12, those values. So again, I'm going to average those 2, and that also gives me a 12. Okay, so there you go. You have your minimum, your maximum, your median, your Q1, and your Q3. Notice they are increasing, right, as you go, which is what should happen with this order. If this from the dot plot is too confusing for you, if you're like, what the heck happened with those dots? Okay, list the numbers. It's not that many, but you also need to also realize that you can only list them with a dot plot that doesn't have that many. So if you want to just look at the values, this is a 7. This is, these are 9, so 9 and 9. These are all 10, so 10, 10, 10, 10, 10. 6 11s here, so 11, 11, 11, 11, 11, 11. 3 12s, 12, 12, and 12. 1 13, and 2 14s. So you could do the whole thing with a list of numbers, and you would get the same exact thing. Okay? You would get the same exact thing. So 20 divided by half, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10th value, an 11th value, that's your median is the halfway. Okay, so then 1, 2, 3, 4, 5, 6, 10 is your halfway. 1, 2, 3, 4, 5, 6, 12 is your halfway. You have your minimum and you have your maximum. Okay. All right. So I'm going to give you guys 10 more minutes to do this. Okay. Because that took up 5 minutes of our time. You're going to do this to the best of your ability. You may want to make sure you do your box plots on a separate sheet of paper. And of course, upload a picture of them, of the box plots before you turn this in. Okay. I will leave this here for you. So 10 minutes on the clock. Yes, I can. So this 5 and the 6. Okay, so after I split my data in half, right, to find my median, there were 10 dots in each half of my data. There was 10 in the first half, 10 in the second half, right? So to find my Q1 and my Q3, I had to take the 10 that were in the half and find the median of those 10. So I did 10 divided by 2, which gives me 5. But just like over here, where when I get a whole number, I have to take the average of that number and the next number, right? So I'm taking the average of the 5 and the 5th and 6th term. Not 5 and 6, but the 5th and the 6th term, right? So that's when I counted here. Oops, wrong side. That's when I counted here. And I did 1, 2, 3, 4, 5, 6. So find the average of the 5th and the 6th term there, right? They're both 10s. So 10 plus 10 divided by 2 gives me 10. And then the same idea, but now for the second half of the data here, right? But for the second half, I count from the lowest number in the second half. 1, 2, 3, 4, 5, 6. So my 5th and my 6th term are both 12s here. So average the 12s and you still get 12. Does that clarify it? Okay. What do you mean, what would not be a whole number? I'm unsure what you mean. Like for this part, how is it that the 10 and 11 value when you divided it by 2? Because I'm not doing 10 plus 11. It's the 10th and the 11th value, Maddie. So I counted in my dots. I found the 10th and the 11th value, or the number, the 10th and the 11th numbers in my data, right? It just so happens that the 10th and the 11th numbers are 11, have a value of 11. Yeah. Okay. Samari Han, I'm still unsure about your question. Like if you divided if you had an odd number of data, right? If you had an odd number of data, like 21 divided by 2 is 10.5. Okay. So as I said, you guys are going to be spending the rest of the class time working on 2.7b. our matching plots activity. What you do not finish in class is homework.